Howdy there, listener. Welcome to Real, Audio Essays and Mysteries. You can call me Carter, and I'll be your host. Come with me as we wade through news stories, mysteries, classified government files, true crimes, cults, and legends. Everyone and everything has a story, and there are so many out there. Some fact, some fiction, but all in need of being processed, analyzed, categorized, and above all, told. So, if you would, please pull up a chair, join me by the fire, and lend me your ear, because I have so much that I want to tell you. Inconceivable. Adjective. Not capable of being imagined or grasped mentally. Unbelievable. This is the word Ted Fujita, many other meteorologists have granted the category of F6. The unimaginable, impossible tornado. It's the reason that, officially, the F scale and now the EF scale stop at 5. An F6 is just, it's impossible, it's unbelievable, it's incapable of happening on planet Earth. An F5 is already complete and total destruction. Nothing left. Annihilation. What can go beyond that? Can't. Or at least, we can't fathom it. It's just inconceivable. However, life has a way of making fact out of fiction and bringing our worst nightmares to life. Many things have thought to have been impossible over the years, but right when humanity thinks it has something figured out, made a rule, a law, or tied our understanding of what can and can't be up in a neat little bow, life decides to show us just how little we actually know, just how bad things can get. Life shows us that just because we can't comprehend it doesn't mean that it can't happen. Life brings out the inconceivable. Over the course of this series, we're going to look at 6 events, 6 tornadoes, storms that broke the rules, set records, and changed the world as we know it forever. Storms that scarred communities for life. These are the storms that some believe should be classified as the impossible and given the F6 rating, some of which Ted Fujita himself considered inconceivable, because he couldn't believe the damage he saw. They broke his unbreakable scale. He couldn't imagine that such damage was possible from a tornado, even in his nightmares. Unfortunately, these events weren't nightmares. There was no waking up to the real world for those affected. No peace to be had. They were real. They happened. And they will never be forgotten. Before we get to the tornadoes and these horrific events that changed the world, we need to understand what the F scale is, what it means and how it's used, and how it's different from the modern EF scale that's used today by the National Weather Service. There's no better place to start than with Mr. Tornado himself, Ted Fujita. Tetsuya Theodore Fujita, commonly known as Ted Fujita, was the meteorologist who invented and introduced the Fujita scale back in 1971 in collaboration with Alan Pearson while working for the University of Chicago. Lovingly referred to as Mr. Tornado by the media, Fujita is responsible for our modern understanding of tornadoes. The Fujita scale, or F scale, was made to assess and rate tornadoes based on the damage that they caused. Analysis of the damage caused would give an idea of the wind speeds of a given tornado, since certain wind speeds were needed to cause certain types of damage. At least that was the idea. Once wind speeds were calculated, the tornado would be given a rating anywhere from 0 to 5. F0s having wind speeds anywhere from 40 to 72 miles an hour, and F5s having wind speeds from 261 to 318 miles an hour. Originally, the F scale went from 0 to 12, so it would connect to the Beaufort scale and the Mach number scale, though only 0 through 5 were ever to be used in practice. And the other wind speeds were thought to be impossible on Earth, especially those at the top, with F12 being the speed of sound. However, Fujita often toyed with the rating of F6. It was believed that 0 through 5 was all they needed, believing that damage beyond F5 would be indiscernible from anything beyond. And F5 was seen as incredible damage that left little behind, usually nothing. Total annihilation. But Fujita himself was unsure, so he left F6 as a possibility for a time, giving it a wind speed and a description, like he did for all the other ratings. F0, wind speeds below 73 miles per hour, damage light. F1, wind speeds 73 to 112 miles per hour, damage moderate. F2, wind speeds 113 to 157 miles per hour, damage considerable. F3, wind speeds 158 to 206 miles per hour, damage severe. F4, wind speeds 207 to 260 miles per hour, damage devastating. F5, wind speeds 261 to 318 miles per hour, damage incredible. And then F6, wind speeds above 318 miles per hour, damage inconceivable. Fujita wouldn't have to wait long, though, before he'd go beyond using 0 through 5 in practice. As the very first tornado he rated, the tornado responsible for the creation of the F scale, was given a rating of an F6. But we'll circle back to that one later. First, we have to talk about the current EF scale. In 2007, the F scale was replaced by the enhanced Fujita scale, aka the EF scale. Similar to the old scale, 0 through 5 are the only numbered ratings that can be given. Additionally, an EFU, or EF unknown rating, was created for tornadoes where there wasn't enough information to go on in order to give a solid rating anywhere on the scale. This would be for tornadoes that hit in remote areas, never hit a town, and there's just really nothing to see. Maybe a giant tornado hit in a field, you don't know what to give it, so you give it F unknown. The current scale looks like this: EFU, unknown, EF0, 65 to 85 miles per hour. EF1, 86 to 110 miles per hour. EF2, 111 to 135 miles per hour. EF3, 136 to 165 miles per hour. EF4, 166 to 200 miles per hour. And EF5, 200 plus miles per hour. Now you see a little bit of a difference there on the wind speeds, especially with the EF5 being much lower than the original F5. Well, the EF scale was created to address concerns that the original scale was inaccurate and rating some tornadoes too highly. It added many damage indicators and took into account the strength, age, and build quality of a structure before it was hit by a tornado. In theory, the scale was supposed to be better, but it has had many controversies since its inception. The main one being the belief that the creators of the EF scale are overcorrecting in their attempts to prevent overrating certain tornadoes, which is why there hasn't been an EF5 since 2013, despite quite a few candidates. Also, despite using modern technology and 28 different damage indicators, the scale is purely damage-based. It's not rating the tornado or storm itself, but just the damage it leaves behind at a certain time, unlike, say, hurricanes, which are rated on wind speeds. The original scale was a damage scale as well, but this was due to the lack of tech available at the time that could measure a tornado's wind speed. Since tornadoes are random, localized, and short-lived events, the only way you could measure their wind speed was to be near it while it was happening and measure it with a wind gauge. Even then, unless you were inside the tornado itself, you wouldn't be able to measure the actual wind speed of the tornado. And this is why surveyors would go out, look at the damage in person, and pretty much make their best guess. They would attach their estimations of what wind speed it would take to do the type of damage they saw, and much of that is still the same today. They just have more damage indicators they have to look for. There's also been an extensive lab testing since the 70s on wood, metal, and other structure types at various wind speeds to see what damage occurs. The problem is, despite these new indicators, the EF scale doesn't use other modern advancements such as the radar. I mean, before, physically measuring the wind speed was the only way to get a measurement, but not anymore. Advancements in Doppler radar technology have given us the ability to accurately estimate wind speeds, and have only gotten more accurate over time. During the 1999 Moore, Oklahoma tornado, otherwise known as the Oklahoma City tornado, a Doppler on wheels was able to record winds of 300 miles per hour, plus or minus 20 miles per hour. That was back in 1999. Despite this, the National Weather Service doesn't take these measurements into account. Though, for that particular one, they did. It's known as being the fastest wind speed on Earth. But recently in 2024, in Greenfield, Iowa, the tornado there measured to have peak wind speeds of 309 to 318 miles an hour, with consistent wind speeds ranging from 263 to 271 miles per hour. However, the National Weather Service official wind speed for the tornado was 185, much lower than practically all other measurements. So how could the two different estimates be so different? Even being strict, you'd think it'd be impossible to have such a different in wind speed estimates. Well, the problem is with how they measure the damage. The way it works is they determine what it would take to cause certain amounts of damage for specific structures. But if all the structures are weak or poorly built, the rating won't be as high. Let's look at it like this. Say you build a house of cards on a table in a field, and there's a gust of wind that knocks them down. Now, you were there to witness the event. You felt the wind, and you know that gust had to be somewhere between 20 and 30 miles per hour. The survey crew comes out, reviews the scene, says it was only 2 miles an hour. Now, you know this is wrong, but they tell you that 2 miles an hour is all it would take to knock the cards over. Based on the damage, that's as high as they can estimate without more info. That's what's happening in most of these cases. It doesn't matter how strong the tornado actually was or how fast the winds were. They can only base it on the damage done. So if your home could only withstand 100-mile-an-hour winds, it doesn't matter if the tornado had wind speeds above this. It's going to get whatever rating it gets. Since most homes today would be leveled by an EF4 tornado, it's nearly impossible for a tornado to get an EF5 rating in 2025. And that's exactly what a study from the American Meteorological Society the study itself called, Where Have the EF5s Gone? By Anthony W. Liza, Harold E. Brooks, and Mackenzie J. Krokak suggest. The conclusion many have come to is that the EF scale is flawed, and it's in need of some kind of drastic revamp, but that's a discussion for another time. While I found the info necessary to share with you before getting into the meat of the subject, it isn't our main concern. But between the two scales, both stop at 5, with the EF scale saying that anything above 200 miles an hour is an EF5, despite many tornadoes since 2013 having measured wind speeds of above that, but again, a topic for another time. Both scales represent the belief that there is nothing greater than 5, and that having a 6 would be pointless, especially with the newer scale making it difficult to even get a 5 in the first place. Both scales show that anything beyond a 5 would be impossible, unimaginable, inconceivable. But what could be worse than your worst nightmare, right? What could be worse than that? So it turned out, quite a few things, unfortunately. And that brings us to our first event. Tri-State Terror. Imagine it's around 2 p.m. in Murfreesboro, Illinois, 1925. You're leaning up against your truck, sucking down the last of your Coca-Cola from its glass bottle. It's been a pretty easygoing day so far. Feels good too. Only about 70 degrees out. Perfect strolling weather. But a cold front is going to be coming in soon. It's going to drop the temp pretty low, maybe 40s, 50s. And with that, it's going to bring along much needed rain to the area. Sounds good to you. Sounds good to everybody. The only problem you've had so far was there was a package that you've been waiting on. It hasn't arrived at the post office yet. It was supposed to be in today, but it isn't. He talked to the postman and he said that the day's deliveries hadn't come in yet, despite it being a little bit later in the day, and that your package was probably with them. Now, he's tried calling the other offices along the delivery route, but no one's picking up. Regardless, they should be here within a couple hours or so. Your package should be here then. You just gotta wait. There's nothing to do in town, at least nothing you wanted to do, so you decide to head home. You can pass the time there by finishing up on some chores around the house. And after that, you might head back to town. Or hell, you might wait till tomorrow. Either way, there was no reason to stick around town, so you hop in your truck and head on home. On your way out of town, you notice a thick, dark fog bearing down on the town. It's probably just that cold front you heard about, and you don't pay it any mind. But you hear a strange sound. It's like a dull roar in the background. For a second, you think it might be coming from your engine, but the sound fades away as you get farther from town. A few hours later, with your chores done, you return to the town to check the mail to see if your package has arrived, but there wasn't a town anymore. The little city you left behind had been rendered to nothing but sticks, bricks, rubble, and fires, similar to the no man's lands you saw during the Great War. This wasn't a war zone from your past in Europe. This was here and now in Illinois. This was your town, your home. And now it was gone. Unbeknownst to you earlier, that dark fog you saw, it was hiding a mile-wide monster hell-bent on devouring everything in its path. Had you not left when you did, you would have been one of the hundreds of victims whose lives were claimed that day along its 219-mile-long path. By chance, you missed it. Survived the tri-state tornado. Long before Mr. Tornado developed the F scale, or had even come to America, the United States had already experienced an inconceivable tornado. A storm of nightmares that no one was prepared for. It happened 100 years ago. On March 18, 1925, the United States experienced a major tornado outbreak across the Midwest and South. At least 12 tornadoes struck that day, killing 751 people over the course of 7 hours. To this day, it's the deadliest tornado outbreak in U.S. history, with the bulk of its body count coming from one singular tornado. One tornado that was on the ground for over 3 hours and tore through Missouri, Illinois, and Indiana. That tornado is known as the Tri-State Tornado. Now, not much is known about the Tri-State Tornado, other than its horrid aftermath and a few eyewitness testimonies. We didn't have a way to measure its wind speeds back then or track it like we do today. We didn't have radar. In fact, much of the country was without electricity at this time. Only 35% of households had electricity in 1920, and the number was growing to 68% by 1929, so this is right in the middle. Communication was also limited, and you only knew what you were told from other people or read in the newspaper. If you had electricity or were near a place that did, you might be able to get more information from the radio, if there was one. But if the tornado was coming, there's a good chance you wouldn't know it until you saw it or it hit. Unfortunately, with the Tri-State Tornado, you couldn't see it. Even in modern day, the only way to officially confirm a tornado is for someone to physically see it and report it. However, this is not always possible. Not every tornado is visible, and it kind of depends on where it is in the storm. You see, many tornadoes are rain-wrapped. Walls of rain and hail shroud and conceal the funnel from view, making it impossible to see. This also makes it impossible to see on radar when this happens. A rain-wrapped tornado looks just like a giant storm, and it wasn't until the advent of velocity radar that the National Weather Service was able to spot and track rain-wrapped tornadoes. But none of that was available in 1925. According to the surviving witnesses, including weather-wise farmers, they had no idea a tornado was coming. The storm front came in, and it was described as a thick fog with a lot of rain. That's all they thought it was. The people didn't know that there was anything to be afraid of, unaware of the monster hiding behind the sheets of rain. What we do know about the Tri-State Tornado is that it was on the ground for 219 miles, and it went through 3 states. As it did, it took with it 695 people and injured over 2,000. It is the deadliest and longest track tornado in U.S. history. From surveys of the damage, it's estimated that, at least at times, it had F5 wind speeds. Though, keep in mind that these are estimations made long after it happened from testimonies and other small damage surveys that were made at the time. But we do know its death count. We got lots of pictures of the cities it destroyed. We also know that it was possibly 1.5 miles at its widest, judging from the scarring left behind on the ground. We also know that 15,000 homes were destroyed, along with 9 schools. 19 communities were devastated, 4 of which were wiped completely off the face of the earth. This was the worst-case scenario. This was the nightmare, a storm unlike any other, with untold damage. But what if I told you that this didn't have to happen this way? What if I told you that the tornado wasn't the only thing responsible for the devastation and the high death toll? At 1 p.m., a fog, or the fog, rolled through Ellington, Missouri, continued across the state. By the time it got to the Mississippi River, the tornado had claimed 11 lives. By 2:30 p.m., the tornado had demolished the town of Gorham, Illinois, and the death toll began to ramp up. The tornado went from county to county, town to town, destroying everything in its wake, killing over 600 in Illinois alone, before moving on to Indiana, where it would kill another 70, before finally dissipating around 4:30 p.m. It was officially on the ground for 3 hours and 45 minutes. That's quite a long time, especially for a violent tornado. And that might have you wondering something. It might have you wondering, why was there no warning given out? Yes, mass communication wasn't exactly a thing like it is today in 1925, but there were ways to warn communities. You had radios, telephones, telegraphs. There could have been warnings, reports sent out. Could have sent out police or just sent somebody to go tell what was going on. Someone could have warned the nearby towns. Something could have been done, right? Well, if you thought that, you'd be right. Something could have been done, but it wasn't. While the initial devastation the tornado caused was sudden, once it had been on the ground for a while, it should have been known about. And it was. Reports had come in, but no one was allowed to tell anyone over the radio. At the time, forecasters weren't allowed to discuss or use the word tornado. It was banned by both the FCC and by the National Weather Bureau. The idea was that saying these words like tornado would cause unneeded panic, especially since they were so hard to predict. However, this wasn't a prediction. This tornado was on the ground and would be for quite some time. Still, nothing was done. The people couldn't see it, nor would anyone tell them it was coming. They were at the mercy of whatever Mother Nature threw at them, whenever it threw it at them. There was nothing they could do. Had an alert or special bulletin been put out, it could have saved countless lives, but nothing was done. See, this idea isn't just hindsight either. The idea of warning people by phone, telegraph, or radio wasn't a new idea. In 1899, a writer at the Chicago Tribune had the same exact idea and wrote to the Weather Bureau. In April 1899, the Chicago Tribune wrote to the United States Weather Bureau via a news article, posing the question on why tornado warnings are not sent out via telegraphs or even telephone to warn the local population in the path. Cleveland Abe responded by saying, "It is certain that if any such arrangement were possible, the Weather Bureau would have done this many years ago. Along with, we must remember that destructive areas of tornadoes and even of thunderstorms are so small that the chance of being injured is exceedingly slight. And we do not attempt to prevent that which is inevitable." This was obviously wrong and incredibly short-sighted. Also just plain stupid. They had the ability to form some kind of warning system, but chose not to. But after the tri-state tornado, they started putting together people to track the storms. It wouldn't be until 1938, however, that the word tornado would be unbanned by the Weather Bureau, though it would still be banned by the FCC for TV and radio broadcast until 1954. In 1948, however, the United States Air Force would issue the first tornado warning for one of their bases after experiencing a devastating tornado a week before. And after noticing similar conditions, put out a warning so that everybody could take cover. This right here is why tornado death tolls are lower in the modern day. It's not just better building methods and stronger material. Weather alert systems and sirens have saved countless lives over the years. People don't always know when to take shelter unless they're told. Not always able to see what's coming. Many at that time thought the tornado was a thick fog, even those who were weather-wise, even those who had seen multiple tornadoes before. They didn't know what was coming. They didn't realize they were staring death in the face. The tornado traveled over 200 miles and across 3 states before anyone really knew anything. And 695 people died because of it. A third of which, by the way, were school children. A tornado is a natural disaster. It's unpredictable, and still very deadly today, even more so back then. This particular one set records that have yet to be broken. However, it didn't have to be as devastating as it was. Those people The people of those states were failed because the government didn't want to upset the public. They would rather people be dead than upset. And that's still a problem that exists today in so many different ways. Thankfully, we've at least learned a bit. The Weather Bureau, which is now the United States Weather Service, or the National Weather Service, has updated their guidances, started a network of spotters, developed warning systems using air raid sirens left behind from World War II, and would go on to develop advanced weather prediction technology together with NASA and the NOAA and the military to better prepare and protect the country from these awful natural disasters. At least they did until the current administration started gunning the NOAA and NWS for reasons unknown, but that's a story for another time. In the future, we may get a tornado that breaks the record for miles traveled, and also for time on the ground, and there's already been some candidates. But due to early warning systems and the diligent watch of the National Weather Service, we should hopefully never see a death toll like the tri-state tornado again. Even worldwide, there's only one tornado that has a higher death toll than a tri-state tornado, and that would be the 1989 Bangladesh tornado that killed around 1,300 people, nearly double that of the tri-state tornado, but under very different circumstances. Though it should be noted that that death toll has recently been challenged again, and said that actually the biggest one is from a earlier one in the 60s, also in Bangladesh. And there's kind of a weird controversy surrounding it that I was not aware until making this episode. Speaking of that particular tornado, we may cover that unfortunate disaster. Maybe even in this very series, but not for a while yet. As for this episode, that's all I have for today. I know they're short and sweet and not the long form you come to expect, but this is going to be a multi-part series, along with other standalone episodes being put out as well. I don't want it to just be all nothing but tornadoes for a while and then we jump into something else. Since these are shorter and I have them written out, put them together, upload them, and then I'll put out something that may be completely different. Maybe in the same week, maybe back to back, maybe the same day. It just depends on when I get them done. What I can tell you is up next, we're going back to the 70s. I guess that would technically be in the future from 1925 to a night of terror in Lubbock, Texas. The tornado that birthed the Fujita scale, as well as the legend of the infamous F6. But until then, stay safe, stay curious, and we'll see you back here on Reel to Reel.